In this demonstration, I'm going to show you how to build a molecular model of alanine in its non-ionic form. That's in its uncharged form. And today we'll be using these kits to do that. If you look in the kits, there are different colors of beads, and they represent different atoms that are present in amino acids. The black beads represent carbon atoms. The white beads represent hydrogen atoms. The red beads represent oxygen. And the blue beads represent nitrogen. There are also two kinds of bonds represented by these short, fat rods and these longer, thinner rods. These will be used for single bonds for the short, fat rods and for double bonds with the thin, longer rods. Okay, so in order to construct a model of alanine, I'll start with that alpha carbon. And so I'm going to just go ahead and place this here. Attached to this will be three groups that are always attached to that alpha carbon in an amino acid. So I'll start with the amino group, which I'll take a nitrogen and add 2 hydrogens to that. This is now the alpha amino group in its non-ionic form. I'll go ahead and add that to the alpha carbon. There is also a hydrogen that is present in all amino acids. I will add that to the carbon. And finally, there is the carboxyl group. So for that, I'll need a carbon. And to make the double bond O, I take 2 of these long, thin rods, and they will bend around and attach to the oxygen. So that's the C double bond O. To make the OH, I attach a single bond to the carbon and oxygen. To the oxygen, another single bond, and then a hydrogen. So this is showing that alpha carboxyl group in its non-ionic form, C double bond O, OH. And so now I'm going to attach that to my central carbon here. So all amino acids contain these 3 things. They contain an amino group, I'll turn this around, an amino group, a carboxylic acid group, and also a hydrogen. What makes amino acids unique is the 4th thing that's attached to this carbon, and that is what we call the R group. Now in the case of alanine, the R group is only going to be CH3, or a methyl group. So I'll put this down. To make the methyl group, I'm going to take another carbon, attach 3 hydrogens to it, okay, and then attach this to that alpha carbon. So once again, now this is the amino acid. Alanine, and it has its amino group, its carboxyl group, the hydrogen, and its R group, which is unique to alanine.